Hello, everybody. Let's see if we can get some. Yeah, we have it on screen as well. So I wanted to try out with a little bit of storytelling here. So imagine waking up, picking up your phone, not that you have it next to your bed, but anyway, let's pick it up there. And this is the first feed you read. Happen to work at Spotify as well. This is pretty scary, actually. So we have something that can execute code in our backend, all our backend services. Yes, they are Java services. That's a pretty daunting way to wake up. It's not true because this blog came up a couple of days later. But of course, somebody was woken up by this security incident. And I don't know, because I didn't see it, but I can imagine the face was basically like this. This is going to be a long day. So yeah, that was a problem a couple of years ago. We know it as the Log4j incident. It's important to us in Spotify because it was a pivotal moment on how we operate our fleet. My name is Stefan. I want to share a little bit on how we were, at least storytelling style, not ever going to be 100% true, but anyway, how we were working such an incident, how we could have been working it earlier, because again, this is why we are working on fleet management, how we take the pain away from most of our engineers. So yeah, how would you do that? What would happen? You wake up, you try to understand the problem right. First question, is this a problem? Yeah, it's bad. Somebody can execute whatever code they like in your backend. That's bad. So okay, it's a problem. It's a problem. Is it a problem for us, though? No, we're fine, right? Because we're using another logging system, so it's all good. It's all good. Aside from the fact that we're also using libraries which are using Log4j. So yeah, maybe not that fine anyway. And also, we have many disciplines. Another one is the data discipline. And we have a data processing framework called Shio, which is also running on the JVM. It's in Scala, but the library is Log4j. It's in Java, so yeah. Yeah, this is kind of a problem. Okay, cool. So the next thing is, of course, to read the incident, understand the fix, apply it. It was pretty easy in this case. There is a next version. This next version has solved the problem. Just update the version of it, test it, deploy it, there you're done. Also, understand the scope of the problem, because again, this was for our backend services, and we have more than two. It actually turned out that we have, at this point, 4,067 backend services running, and 1955 data pipelines running. Okay. This is going to be a long day. So let's get on with it then. Let's actually realize that I'm not going to do this alone. So let's get a team together. We assemble the key people needed in order to reach both disciplines, in order to reach the folks, in order to apply the fix, etc. So yeah, we set up this war room. Sorry for the reference, but anyway, that's what we're still calling it. What would we need? Well, we need a chat where we can find out their sharings, etc., etc. Of course, we need a virtual meeting. Let's get going. Let's create a plan for how to fix our software fleet. This plan will include, let's make sure everybody are on board and fix their shit. Because in Spotify, we think ownership is very important. So you own and you operate your own stuff. Okay, cool. So we set up a public communication channel. We set up another chat which they can be in. We set up a meeting that they can jump in and understand the problem, the questions, whatever they have. And also we reach out to everybody. We send a mail saying this is urgent and important, it's pretty scary. And in order to not get caught in everybody's ignore list with all capitals, I'm adding a little bit, please fix it, Stefan. Again, hypothetical. But anyway, let's roll with the story. So yeah, and everybody doesn't read mail all the time. We page them to get into it. We start communicating with everybody. We make sure that they know about this. We make sure that they do the changes. So please apply this trivial fix in a one line, in your dependency management, and get somebody to review it as well, right? Because that's what we do. We're responsible. We review all the code. Okay, I could argue this wouldn't be the case. We shouldn't review it because it's a typical break the glass change. But anyway, that's what typically do. Good. Aside from the ones we didn't reach with the page. So let's make sure we get in touch with all the owners that aren't on call or didn't read the mail, or where the owner feel no longer is true, or the squad team no longer exists, etc. Yeah, there's always a bunch of long tail when you're trying to update, at least for us when we update in complete fleet. So that's one of the challenges. But anyway, you do that, you get to a place. I'm sure you also start assessing what was how much of the problem was Was there any actual security breach in this case, or did we manage, etc.? You bring this to the incident review, the postmortem analysis. You say, good work, team, because damn, a good work we did. Lots of work, at least. We try to assess the impact. Did somebody actually breach us or not? And then we also ask the very important question. What should we do for next time to be ready? Okay, cool. 2 obvious things pops to mind. Let's be proactive next time. May not help for the 0 day, but it may help for a bunch of other ones, so fair enough. And also, let's put some automation in place so we can do this quicker next time. Yeah, that sounds good, right? We had already been around this one, so when we came to this incident, we were slightly more prepared. That was good. We're gonna still do the same thing. Is this a problem? Of course it's a problem. Is it a problem for us? Yes, it's still a problem for us. We understand it. We try out the fix, we upgrade, we test, we deploy it. But then we start doing something differently. We do not try to communicate with everybody. Instead, we started doing what we call a fleet shift. We prepare the change in a way that we can apply it across the fleet. That's the main difference here, right? And it still applies to all our services and pipelines, of course, and that's good. Then, it's a major deal. This is not a silver bullet. It's just making it easier. We still need a team to get together. I think we actually were as much as 50 people working on this, even though we had the automation. So we assembled that team, we set up the infrastructure, we create a plan on how to approach this. But since we had already started creating this fleet shift in Sweden, because that's where we're located, Halflab is, when US is coming in, they're ready and we're just starting to roll it out. But still, we communicate with everybody, right? We send out a mail, but it's not do fix this. It is, okay, we have this incoming, right? So be aware, be on your toes in case something happens. We can skip the paging part. We can skip the reaching out to them. To some extent, we run the fleet shift. We apply the change to all our services, all our data pipelines, and we auto-merge it. And on auto-merging, it's being continuously deployed. It's deployed automatically. But now I need to be honest. Yeah, we don't hedge on everything on one thing here. So we also asked all owners to make the change. So we let it go in parallel. Not sure we would do this now 3 years later, to be honest. Okay, cool. So that's how we did it. And then we came to completing the work. Still a long tail. Okay, fair enough. But instead of the hypothetical multiple days chaos, we were done after 11 hours with 80% of all components. They were updated, they were deployed, they were running in production without incidents. 2 days later, we were actually 100% done. Oh, no, sorry, 99% done. 5 more user repos may or may not have been deployed. We still needed to handle them. Okay, cool. And now we come to the incident review, and yeah, still good work, right? We did a bunch of work. We did fortunately at least, not have an impact. So that was good in this case, as far as we know at least. But we also asked this question: why did we not reach 100% with our automation? What can we do in order to get there all the way? And there were multiple reasons, and one of them being CI, flaky, or for numerous reasons. But one which was pretty important that caught our eyes was that Fleet Shift bot, which is the thing applying the change, actually was disabled. This is not only about automation. There's something more to it. So we needed to work a little bit on our culture. And, don't waste a good crisis. We used this one in order to change how we were working on it. This was the pivotal moment. So taking a couple of steps back here. Why are we at all in the business of fleet management? Why do we think it's so important to be able to work on the complete software fleet? We are a microservices shop. We have a bunch of teams. I think we are around 700 teams right now. Each team owns 1 to 2 to 3 systems. You know it from the system architecture we have in Backstage. We have a bunch of components inside each system. Why split between squads and systems? Well, because systems and software live a lot longer than teams, right? We learned this, Conway law work. So yeah, a system is a bunch of components, services, websites, etc. Inside these, there are a bunch of instances. This is how we reason about our fleets. I think we have around 200,000 software entities in our catalog. Okay, cool. So this is what we need to work with. We concluded that we had a microservices shop then, where each team owns their stuff. Again, ownership is still important. And we were growing. These were somewhere around 2017, I think, but I'm not going to take poison on that one. We concluded that, yeah, we are growing faster in our software fleet than we are growing in engineering culture. And engineers were also growing up until recent years. But still, our software grew a lot faster. And to put another number of this, the number of lines of code each engineering Spotify owns has doubled in the last 2 years. So that's a problem. So what do you do with such a problem? Well, you invest in taking care of it. Another way to look at this, how long time does it take to take care of our fleet? This, we're looking at a standard migration. We moved from Java, I don't remember, we say Java 9 to Java 11, just to put an old number. And we started working on it in March. And then we went component by component and updated it. And 10 months later, we're close to done. Good job, right? But not super snappy, I can't say that. So yeah, how do we change this? This is the reason why we came to, we need automation. And we need to change from a component-first mindset, applying our SRE thoughts, to a fleet-first mindset. When we want to make a change, and it's good, we want to make it across the fleet. Cool. Let's build some automation. So we as you saw, we can make a change. We call it a fleet shift. You might be the author of a fleet shift. You go in and you create it. Not super interesting yet, but anyway, it has a target. This is our dependency update shift. It has 2,560, all our production services right now, as a target. It updates the BOM. BOM is a bill of material. It's the dependencies we have, which we share in common and update accordingly. Thanks to this, we actually have more or less a single version policy in our polyrepo world. Okay, cool. So you create this fleet shift, and what does it do under the hood? Well, this is the change we're going to be making. Update all the updated dependencies by modifying the version of the BOM in all repos. Under the surface, this service will take the manifest you just saw, or the summary you just saw, and it will do exactly what a human would do when it was tasked with this. It will create a couple of Kubernetes jobs, one per repo. That job would clone the repo. It would set it up and launch a Docker container, which makes the code transform, or the text transform in this case. Once done with that, it pushed the changes to a branch, and then push it up to GitHub. Okay, cool. And then it does that for each repo. What Fleet Shift then does is watch the progress on this one and keep track of it. Once you're done with the change, it creates a pull request, and there we go, right? Each team get a pull request. Awesome. Yeah, took care of it. Well, a lot simpler, right? So we have a list of changes. Again, this was 2000 something. All the repos, all the PRs created. All good, aside from a little bit of problem, because we're doing this maybe once or twice a week on each repo. There are a lot of code reviews. So what can we do to this? Well, I mentioned it already during the incident review. We want to auto-merge these stuff. But in order to auto-merge, we need to be ready for that one. And here was the cultural change, right? How can I let anybody else, or how could I let automation go make change to my component? I need to be prepared for that one, and I need to allow that to happen. Okay, fair enough. So let's work a little bit with the readiness of the fleet. So what we do, we create we realize what do we need in order to be ready. Well, we have to have tests. They need to run. They need to have a decent coverage, and they also need to pass. So we always have a releasable main. That's good practice anyway. So no surprises, but let's really work through it for all components. And then we also need to have a little bit of monitoring set up, alerting set up, etc. And that's all good. We also need to be able to make those changes. And if everybody do whatever they like, it's very cumbersome for us in platform to make the changes to whatever technology they have. So this was the second time we realized that, yeah, it's really good if we use the same technology. So we introduced this standard terms, and for those who have seen Spotify from the trenches or Agile from the trenches, we're pretty famous for being autonomous. We still want to do that. We still want to make our own decisions. But maybe, just maybe, it doesn't help if we make a new technology choice every day. So that was the change we introduced. So we identify which technologies are in use, the green ones, and which is our blessed technologies, the golden ones. So yeah, golden tech allows us to do a couple of things. It simplifies for building software for our engineers, and it unlocks us to run fleet management. Really, really good. In turn then, here comes the promise back. We can maintain all these components for free. Once you're golden, you stay golden. I'm going to do a knock on that one, and I'm also going to realize there are some exceptions. But that's the motto, at least. We take care of you. And we actually also use fleet management to level up the technologies and use the standard one. So that's how we do the migrations. Cool. And then we realized that, okay, this was good. This was an effort, a campaign we made to get everybody on fleet management. The crisis was used. We really, really saw the value of fleet management in this part. But we want to stay this way because we want to continue to do it. So then we kind of introduced this golden state concept as well. So here's the things we want a service to do. The technologies included using the BOM you just saw, also the base image, also using the same kind of service which uses the same kind of logging. We call it Apollo internally. It's not the same Apollo service that exists out there in a couple of flavors. And we also use what we call declarative infrastructure, because this doesn't have to stop with just the software components. There are also a bunch of other things we can fleet manage. What if we can take care of all the resources, the databases, the autoscaler, everything else? Locus, brilliant name or not, I don't know. Anyway, it's our caching service, caching layer. And when we're starting to declare this, it's just a text replacement, right? So that's why fleet management and updating components when not enough also roll out GitOps for all our resources, which makes it possible to make changes. In this case, we changed it not to the locus, but to the big table, the second example. We changed how we configure the big table clusters and saved a bunch of euros actually by just reducing the number of minimal nodes and cranking up the scalability so we can handle a bit more load, because we had verified that that works. And now we in platform address that across the fleet. Okay, cool. So then we have the automation in place. We have worked a bit on the readiness, so the culture is coming there. How does it work then? Well, you see the same picture in the middle here. We have the fleet shift, which pushed the changes to GitHub. When a PR is available, CI runs, of course, before merge. And when that is passing, we have the auto merger at the top of the right one, the one that will be continuously reviewing for PRs by fleet management. And if this shift is one that we can auto-merge, it will do so. Once it's merged, CI runs, passing the test, pass it on to the deployment system starts deploying it. All good. We have another service which is making sure that some guardrails are still nice. We're letting automation go wild here, that it doesn't start breaking. So we roll it out, cohort by cohort, and if we see any issues out of the ordinary, that's when we break it, or we alert the fleet management team. Okay, cool. So this actually put us in the spot where we could handle this incident a lot better. And the developers coming to the realization that this is fine. Okay, it was cool when I got the PR automated, but also pretty boring to read them. Now I can just go back in time, and if something happens to my service, I will look at the history, and that's the only team I need to interfere. And that's really, really good. We've trained the developers at Spotify, me included, to not really care about the fleet management PRs anymore. Actually, slightly too much, because we're having a new problem, and that's when they start failing. People are still not looking at it, but that's we'll get to that. We'll sort that. Cool. So yeah, where are we now? We're making a couple of different changes. We started out with targeting repos, polyrepo, one repo, one component. All good. You feed it a list of names. Pretty soon we realized, yeah, we need a data set which you populate with a list of names. And then that was all good for us in platform who wanted to take the time to prepare the fleet, the data set, etc. But the next level was then we could integrate this in our code search system. Then you could just find, I mean, in the original case, you could search for log4j 1.4.12, I think it was, doesn't matter, and you would find it. You would also find it by metadata. I only care about the services, and the language is Java, and then I could make this change. And then we also embarked on the journey of monorepos. We have had our client code in monorepos for many years. Here it's not really good at applying the change at the root of the repo. This is where we need it on a component type, based on the component types, and based on repo and path, because that's how you identify a component in the monorepo. So cool, that's what we can target, meaning one component at a time or one system at a time. We see a couple of different changes we want to be making. The first one was the simple change, just a text or a regex. That's how we got the dependencies updated. That's how we fixed the cost for Bigtable. But we also want to take care of more. So what we saw that we were getting a lot out of fleet management in the simple one, and then we compare to others and say, but what else? What other changes should we be doing, etc. What more can we do? So we started going to code changes. Maybe we update the Beam version in our CU pipelines. Okay, fair enough. And here we go into AST transform, apps of syntax transform, meaning we're changing the source code. We can update APIs. We can deprecate APIs. We can also handle breaking version updates with this part. Cool. We also go into code cleanups. We identify a problem, and we apply the change across the fleet. And of course, this is good, but of course, we want to do more of this. So where we are exploring right now is where so many of us are. What can we do with AI? How can we get these nice LLMs to make the more complex changes for us, but not just in our IDE, but also apply it across the fleet. Let them loose and do it to all the fleet, because they love simple, repetitive tasks with very clear instructions. And what we believe, what we're exploring now, what we believe is that we can move in a couple of migrations, code migrations, that we have not been able to do before. We also recognize that some we can do completely. We're never going to go without human review here, or never, I shouldn't say never. We're not going without human review not now. But even if we cannot make it completely, if we can make it 90% of it, that's actually a big win as well. So that's what we're playing with right now. So did this help us? Yeah, the time for doing migrations, you remember for the Java one, it was 10 months. How far did we reach for 70%? Is this what this graph is showing? How many of the migrations have we completed? Or how long does it take to complete 70% of the migration? And we see, as of 21, this is becoming fairly low in the order of 1 to 2 weeks. Also, and that means that we're actually shipping new features to our developers in this time frame. We also recognize that we can expand the usage of it. Here you see the graph of how many human PRs we're making. Ideally now freeing up time for the humans so they get to make more interesting PRs, and that is slowly going up, which is good, of course. But we see the bots going a lot faster. So 3-to-1 ratio, bots versus humans. Of course, then humans making the interesting one. I'm not going to deny that. But what we're also seeing, and as I mentioned with code search integration, we're having more and more change makers. So it was not only us in platform that benefited from this platform. It is also the platform teams outside in the organization, the feature platforms like, hey, I'm changing my API. And it's the one that does what I love, to clean up our production environment, renaming the metadata, just making it tidier. So there's a lot of change makers growing. And the promise to start with here was, how much time can we free up for our engineers? How can we set them free to do the feature engineering work, right? And we calculate this in a pretty cheesy way, but anyway, each PR, which is trivial, we call that 30 minutes of work compared to if you got a mail, and the more complex one can be calculated as as much as 2 hours, which is very far from true if you would have done it yourself, but it's okay. And in the end of 2024, we had saved as much as if 355 engineers were working full-time during that year of time. If you're interested in learning more, this is where you get to know more. We have produced a podcast on this. I think it's NGN who's being interviewed, our chief architect. And we've also produced a couple of blog posts on this one. So please feel free to reach out and read them. And that's what I wanted to share. Thank you.